Here is a video introduction to RD2ESCODE Code, an embedded code generation tool. In today's highly competitive market environment, rapid product iteration and shortened time to market have become critical factors for enterprise survival, with agile development methodologies being widely adopted for their ability to quickly respond to market changes and user requirements. However, agile development in embedded systems faces unique and complex challenges. First, traditional embedded code generation tools primarily rely on graphical interfaces, predefined templates, and model-driven approaches, lacking the capability to understand natural language requirements. Developers must manually convert requirement documents into configuration parameters, a process that is both time-consuming and error-prone. Second, existing code generation methods mainly focus on basic hardware abstraction and driver code, lacking intelligent adaptation and reuse mechanisms based on reference code, which prevents teams from effectively leveraging existing code assets. Furthermore, embedded development requires deep knowledge of underlying hardware and specialized programming skills, creating technical barriers that limit team member flexibility and further exacerbate development cycle delays. These technical bottlenecks create a sharp contradiction with the market's urgent demand for rapid delivery, severely constraining the responsiveness and innovation capabilities of embedded products in fierce market competition. There is an urgent need for more intelligent and automated development tools to break through this impasse. Currently, solutions mainly rely on predefined templates and graphical interfaces, which, although intuitive, require developers to manually translate natural language requirements into configuration parameters, a process that is both time-consuming and error-prone. Additionally, most existing code generation approaches focus on basic hardware abstraction and driver code, lacking intelligent adaptation and reuse based on reference code. These limitations hinder efficient response to rapidly changing requirements and reduce code reuse, which runs counter to the core principles of agile development. To address these challenges, we propose an LLM-based intelligent code generation tool that combines a graphical user interface with advanced natural language understanding, enabling rapid generation of high-quality simulation and test code based on reference implementations. The main advantages of our tool include 1. Natural language requirement, comprehension, and intelligent adaptation. 2. Intelligent reference-based code generation and optimization. 3. Interactive code explanation and knowledge transfer. In contrast to prior LLM-based code generation research, our approach specifically addresses the unique challenges of the embedded systems domain. The generated code must interact with specific hardware components and adhere to real-time constraints. The quality of the initial code directly impacts subsequent hardware testing efficiency, and frequent requirement changes necessitate rapid regeneration of feasible code for iterative evaluation. By generating high-quality initial implementations that accurately interpret hardware interfaces, timing constraints, and embedded specific programming patterns, our method significantly reduces the manual effort required to convert requirements into testable code and accelerates the overall development cycle without compromising the rigor of final system validation. The agent optimization process consists of 3 key stages: construction of the reference knowledge base, initial code generation, and iterative error correction with feedback. To demonstrate that RD2ESCODE is capable of generating high-quality embedded system code, we present a comprehensive case study using a small-scale embedded system, the Intelligent Dual-Axis Solar Tracking System. An illustrative example. Now let's introduce our tool. The user needs to upload 3 files: requirements document, reference code, reference requirements document. Then tell the tool to start generating code. During this process, the model will let you know which step it's currently on. The whole process will take a few minutes. Once the code is generated, you can click to download both the generated code files and the corresponding compiled files. and you can also click a button to open and view the generated code files. If you have any questions about the generated code, you can talk to the agent to get answers. Our tool integrates Proteus 8 Professional. You can click a button to open the application and run simulation tests on the code generated by the tool. Here, we're using a test environment that has already been set up in advance. Click to open it and put the compiled code files generated by the tool into the test environment. After testing, we found that the model basically meets the functional requirements outlined in the specification. All of the above documents can be downloaded from our open source website. You can click on Thought Process to view the communication between the different agents, and you can also see the prompt design for each agent. Similarly, here you can click to download the code files generated by the tool at different stages. In step 2, you can view the conversation between the code generation agent and the compilation feedback agent. In step 3, you can click to download the 3 different styles of reference code generated by the reference code generation agent. Similarly, in steps 4, 5, and 6, you can see the interactions between the reference code generation agent and the compilation feedback agent. In step 7, you can see the code optimization suggestion agent providing revision suggestions for the code based on the initial code agent's output because of the unique capabilities of large language model. Even if we use a requirements document written in Chinese here, the model can still understand the content. In step 8, you can see the process where the code generation agent revises the code based on the optimization suggestions, as well as the compilation feedback process.